title of this note is Inverse Trig, and the outcome is that you're going to be able to evaluate an inverse trigonometric expression. So we've actually seen a couple problems like this. So here we have a triangle, and we want to know what's the measure of angle L. So all we know are two sides. And in relation to angle L, the side 35 is opposite, and the side 65 is adjacent. So that means that we know the tangent ratio. But what if we want to figure out the angle? Let's talk about how we're going to do that. Because we have the tangent ratio, we know the opposite over adjacent. What we can do is we can do the inverse, so inverse tangent of opposite of adjacent, and that'll give us the angle. So likewise, if we know the opposite and the hypotenuse, we do inverse sine of the opposite hypotenuse to get the angle, or we do inverse cosine of the adjacent hypotenuse, or inverse tangent. Be very careful. That -1, we're never going to say -1. It's a symbol that represents the inverse. So down here, this text, it's important this text ends up in your notes. This expression, which is read inverse sine, does not mean 1 over sine. 1 over sine is the reciprocal, not the inverse. The -1 is not an exponent, it's an inverse symbol. Remember, for inverse functions, like f inverse of x. So let's go back to the original problem. So in relation to angle L, we have the opposite and the adjacent side. So we can calculate the inverse tangent of 35 over 65, and that'll give us the angle theta. In your graphing calculator, we'll actually do this. I'm going to show you on mine really quickly. So right here you have your sine, cosine, tangent. If you hit second tangent, it'll bring up the inverse tangent. So those numbers were 35 and 65. Now, I'm not going to get what's on here, because if you notice, it's 28.30 degrees, and my calculator right now is in radian mode. Sometimes you'll be asked for radians, sometimes you'll be asked for degrees. So it's really important that you're paying attention to your mode, and you may have to switch back and forth. So I've scrolled down and I've highlighted degree mode. Now let me try again. So there's my answer in degrees, 28.3 degrees, which you can see is what we expected to get. So what if you don't have a calculator? You can find the inverse tangent or inverse trig ratio of any angle if it's on the unit circle. And if you're asked to give an exact answer, that means no decimals. So like radical 3 over 2, you're not going to give that as a decimal. So sometimes we have compositions, which means we have a trig function inside of a trig function. You want to think about SOHCAHTOA here, and you're going to want to draw a triangle. And you're going to simplify the expression from the inside out. So let's take a look at this first one. So we have the sine of inverse sine of 1/2. And this is without using technology, so it means we're not touching our calculator. So let's draw an angle that has a sine of 1/2. Rather, a triangle. So the sine is positive, so it could be in this quadrant. There's my angle, always the angle by the origin. And I know that sine is opposite over hypotenuse because I'm thinking of SOHCAHTOA. So that means the opposite leg could be 1, the hypotenuse could be 2. So if I want the inverse sine of 1/2, I want this angle. So this is theta. And so if I simplify that inside stuff to theta, now the equation reads sine theta. Well, what's the sine of an angle? It's the opposite over the adjacent. The opposite is 1, and the adjacent is 2. So the answer is 1/2. Okay, so now let's look at number 2. So we have cosine. Again, it's positive, so I'm just going to put it in quadrant 1. All right, so we have the inverse cosine of radical 3 over 2. Thinking about SOHCAHTOA, my adjacent could be radical 3, my hypotenuse could be 2. So the inverse cosine would give me this angle here. So now I have the cosine of that angle. The cosine of that angle is the adjacent over the hypotenuse. So radical 3 over 2 is the answer. All right, and then the last one, I have the tangent of the inverse tangent of radical 3. And all these as fractions, so I'm just going to put that over 1. Might work for number 3 right now. So that means the opposite over the adjacent. The opposite is radical 3, the adjacent is 1. So the inverse tangent gives us theta. And then the tangent of theta is the opposite over the adjacent, which is radical 3 over 1, which I can simplify to radical 3. So the answer to number 3 is radical 3. And I hope you've noticed, wait, each time the answer was the number that was inside the function. That's because inverses cancel each other out. Sine and inverse sine cancel each other out, so the answer is 1/2. Cosine and inverse cosine cancel each other out, so the answer is radical 3 over 2. Tangent and inverse tangent cancel each other out, so the answer is radical 3. All right, let's look at some that aren't quite so obvious. So we're going to take the cosine of the inverse sine of 1/2. So again, I'm going to draw a triangle. I'm starting with the inside. I want an angle such that its sine is 1/2. So sine is opposite over hypotenuse. So all of this is equal to theta. So now I want the cosine of theta. The cosine of theta is the adjacent over the hypotenuse. Well, I don't know the adjacent just yet. So what I'm going to do is I'm going to do Pythagorean theorem to solve for it. So I get that this is the square root of 3. So the cosine of that angle has to be the square root of 3 over 2. So notice how we're doing all of this without ever actually figuring out the exact value of theta. All right, let's take a look at number 5. The tangent of the inverse cosine of 1. So first, starting the inside, we're going to draw a triangle such that the cosine of an angle is 1. So cosine is adjacent over hypotenuse, so 1 over 1. And all of this is theta, so this now is the tangent of theta. Tangent, think about SOHCAHTOA, is opposite over adjacent. So I got to figure out the opposite right there. Okay, so solving for this, Pythagorean theorem again. So 1, subtracting 1 from both sides, I get b squared equals 0. So this is actually 0. So then the tangent is the opposite over the adjacent. So 0 over 1, which is 0. This triangle doesn't quite make sense because the hypotenuse and the adjacent are the same. If I go to the unit circle and think about what angles have a cosine value of 1, I'll see that it's actually 0 degrees. And so here's another way I could do this. I could look at the unit circle and go, oh, that angle is 0. And the tangent of 0 is sine over cosine, 0. So you can do it unit circle or with a triangle, either way. All right, so last one, let's try number 6. Let's do this one on the unit circle first. So starting from the inside, what angle in the unit circle has a cosine value of radical 2 over 2? I know that right there, this is pi over 4. That has a cosine. So let me write the whole thing. The sine of the inverse cosine of radical 2 over 2. Working from the inside out, this angle is pi over 4. And the sine of pi over 4, again from the unit circle, is radical 2 over 2. that's one way to answer number 6. If you're not a fan of the unit circle, you can draw a triangle. So you can say, all right, let me draw a triangle that has a cosine of radical 2 over 2, adjacent over hypotenuse, and then I want the sine of that angle. Well, I got to figure out the opposite, so I got to do Pythagorean theorem. A squared plus b squared equals c squared. I can see that b is the square root of 2, so sine is radical 2 over 2. So with a unit circle, with a triangle picture, either way you're going to get the same answer. So what you're going to do now to end your notes is you have 3 to try on your own that are really similar to all of the examples that you just saw. And we're going to go over these in class.